So, Firehawk, what is it? In a nutshell, it's a web platform for wildfire rapid risk evaluation that produces fire growth modeling through Prometheus software as a service, PSAS, and it uses the fire behavior prediction system from the CFFDRS, as Prometheus does already. The vision of this is to develop a national tool for operational fire growth modeling that can be coupled with other fire intelligence models aiming at bringing fire management planning to a higher level. This all stemmed from some work that has been funded a few years back by Defense Research and Development Center for Security Science, so DRDC CSS. This is some work that was done by Geological Survey of Canada that developed a proof of concept tool called the Rapid Risk Evaluator, so ER2, for earthquakes and floods. And the philosophy behind this tool could be summarized with this quote here. So while Canada is exposed to a variety of natural hazards, most emergency managers currently lack the necessary tools and guidance to adequately undertake rigorous risk assessment. As opposed to a complex model used by a small number of technical experts, a user-friendly rapid risk assessment tools referred to as ER2 is being developed to allow non-expert users from the public safety community to run their own otherwise complex risk scenarios at the press of a button. Once they developed those proof of concept, they thought that it would be interesting to develop a module for a third natural hazard, which is wildfire, and they reached out to CFS for that, and I accepted the idea and went forward with this project with the RDC mainly. And the idea is to rather to help the wider risk management community, but the wildfire tool is mainly the main clients and users that are foreseen are Canadian wildland fire management agencies. What drives the direction we took with the development of this tool is mainly to support agencies' decision making when they're facing new fires. And many questions are arising when there's new fires. Agencies wants to know how big the fire will get and what its potential fire behavior, to then answer other questions such as how many resources by type should be sent for initial attack, what are the chances of success of this initial attacks, how to plan for the following days. And they also want to know when and where the fire will burn. So this helps them evaluate the values and assets that are at risk and if there are human lives that are threatened. When there's multiple new fires detected, it's the same questions that comes up, but they're obviously repeated as the number of fires. So if the resources are limited, as you know, a triage needs to occur. So agencies need tools to integrate the different information. So fire weather, fire behavior, suppression effectiveness, values at risk, all of that in a timely manner to take proper decisions. So what they have as tools for now is fire growth modeling. That is one way to efficiently assess fire hazard. As you know, this could be done by hand through tools such as Red App, paper maps, or using software such as Prometheus. And it could take between, let's say, 15 minutes or an hour to run a scenario. And it takes a specialized resource to run those fire growth modeling scenarios. And these resources quickly become scarce when the fire workload is rising. But even once they have the fire hazard model or the fire growth model done, there still need some information that needs to be coupled with that. So let's say position of values and infrastructures on the landscape and resources needs and effectiveness and other questions. For researchers, a tool such as Firehawk could be a place to put our models into application. It helps ensuring our work could be applied operationally. It may improve the uptake from the end user as compared, let's say, to a scientific publication. It could also help a CFS fire growth modeling service by reducing the allocation of human resource to fire growth modeling, but also to improve the turnaround time for those fire growth modeling. So the funding we had by DRDC for what we now call phase one, that started in December 2020, and it's ending by the end of March this year. The objective of this project is to develop a GIS-based tool to support wildfire risk assessment and short-term decision-making for planning around, let's say, resource deployment, fire prioritization, protection of values at risk, and evacuation, for example. This is done through two features that we're developing. The first is fire growth modeling, and the second is simulating risk to values and assets. The first is divided in two approach. The first is automated fire growth modeling. So for day one of each new fires that are detected or known in the system, we'll have a simulated growth model that is going to be started. And then we'll have the supervised fire growth modeling that is going to be available. So that's for active or simulated fire. It could be useful for planning day 2 and 3, and where some parameters are going to be chosen or set by the user. The second feature is mainly for now measuring distances from the simulated fire parameter to the different values and assets. For now, and the funding we receive is to put up a proof of concept. So just keep that in mind for now. So the first feature, just to put some image on that. So let's say that we have a new fire that's detected here in northern Quebec. So for a new fire like that, we will have a simulation that is going to be automated, and we are going to be able to output fire parameters on the selected time step for the duration of the simulation. And this is going to be output on a GIS-based mapping service. In more details, how the feature is working. So for all new fires in Quebec for now only, there will be an automatically simulated by Firehawk for their first burning period. So the platform provides input for fire growth simulation. So it provides fuels and topography. It provides weather forecast, simulation parameters that are presetted, and the position of the ignition point. And then a Firehawk retrieves fire parameters, polygons for each time step from PSAS. It displays them on the map and archives them. So just to give you a better image of how it's working underneath the hood. So we have those preset inputs. So we have FBP fuel grids. For now, we have, for Quebec, we have subfirst 100-meter raster, but we also have a national layer that's been put up by our colleague, Sam Lacarte, that could be used at 100-meter. We have the matching DEM for topography, and we have presetted the simulation parameters such as the duration. So from the start of the fire to, let's say, 2200 at night, we have a hourly temporal step, and we have presetted spread limitation. So for example, we could set FWI value larger than 12 to allow fire growth. And then we have those dynamic inputs. So we have the ignition point coordinates parameter that could come for now. We're connected on the CWFIS database, but we have them in a more timely manner, directly coupled with subfirst database. From that ignition point, we extract a 25-kilometer buffer around ignition for both fuels and topography. And we go and grab weather forecasts on Environment and Climate Change Canada's website, their RDPS model at 10-kilometer resolution. This is all thrown into the PSAS API, and it returns fire parameters polygons for now, but we also have access to those that other information. So intensity grid, rate of spread, and fire type. Within the first feature, we also have the supervised fire growth. So this is pretty much the same. It works pretty much the same way. The main difference is that the user provides input about the simulation parameters. So it could modify the time step. So let's say between hourly to daily, and can set the duration within 84 hours of the RDPS forecast. And it can set the ignition point or parameter. So underneath the hood, it's pretty similar. So we have those preset inputs, fuel grid and DEM for topography. We have some simulation parameters that it can be dynamic now. So like I said, duration and temporal steps, spread limitations are on the work now. We don't have direct access to that, but the programmer has. We have the ignition point that are defined by the user, and then as in the previous function, we have automatically extracted fuels and topography and weather forecast to output the same fire parameter polygons. So then our second feature about simulating risk to values and assets. So if we start with the same fire growth simulation that I showed earlier for a fire in northern Quebec, and let's add on the landscape two telecom towers, so tower A and tower B, and we will output a table with some indication for all the values in the landscape, mentioning if the distance from the ignition point to those values, if those values have been reached during the simulation, the time that it reached the value, if reached, and the distance from final parameter. Again, just a quick view of how it is underneath the hood there. We're adding in blue the second feature. So fire parameters polygons are sent, well, they're already in Firehawk. And then we have preset inputs such as values at risk, let's say telecom tower layer. And then Firehawk calculates distances and outputs a table similar to what I just showed. Now we're going to go through a short video demonstration of the web platform. It's about 4.5 minutes, where you'll have about a 25-30 second fire growth simulation. So let me know if anything's not working. I'm just starting that. Hopefully you
Hello
hear the sound.
everyone, I'm Alex, and in this quick demo I'm going to show you an early version of the web interface for Firehawk. I pre-recorded a video to make sure I don't come across some unknown bugs that still need to be ironed out. As I said, the interface is still in early development and there are still a lot of things we want to add. However, the majority of the work on the system underneath has been completed. With that said, let's jump into the demo. There's not much to say about the landing page, so let's go into the map. Alright, so right after loading, you can see that there are already a couple of layers visible. We can go through them by clicking on this button. So the first layer is the automated simulation fire perimeters, which contains the perimeters generated by our servers checking constantly for new fires in the subfire database. So this means that right now, this only works for Quebec, but we would eventually like to expand it to other provinces. Normally, we would show the perimeters of the simulations run today, but since we are in the middle of winter, here is an example of what it would look like with a fire we simulated this summer. So once it finishes loading, the perimeter will appear in red. All right, there it is. This is what it looks like. Next, we also have a couple of layers to assess the wildfire situation in Canada taken directly from the CWFIS. These are the active fires and the fire perimeter estimates layers. Then we also have the points of interest and the power lines, which are layers provided by software to evaluate the values at risk. After that, we also have a couple of interfaces, which are used just for reference. And finally, we have the fuel types and the elevation layer, which are used behind the scenes to feed the data into PSAS. So to end this demo, I'll just launch a quick simulation by clicking a spot on the map. You can also look at the bottom left corner to move your cursor at a precise location, as you can see here. So let me just zoom in into a spot. All right, so let's click this spot here, for example. And let's wait for the simulation to finish. All right, the results are in, and you can see the predicted fire perimeter on the map. The perimeter is based on today's weather, but again, since we are in winter, I adjusted the temperatures a bit manually so that it would create an interesting perimeter for the demo. So that's pretty much it for now. In the future, we will continue to have a small model window open where you can adjust some parameters for the simulation, such as the dates and the burning conditions before launching it. We also want to show some information about the visible layers when you click a spot on the map. So for example, we could show the name of the fuel at the precise spot the user clicked. As you can see, there's still work to be done, but we think the foundation is here. So thank you, everyone.
All right. So as you saw, it's I know it seemed long during the video, but the simulation itself, once Alex, the programmer, started it, it took about 25 to 30 seconds to actually run a scenario, and we expect that it might be around the same time once the Firehawk is deployed. So in terms of development philosophy, this is maybe more for the developers or the programmers, but the interface is being developed uh, in a way that can be used by anyone. So it will be accessible from a URL in your browser. Secure access will need to be defined later on. The underlying system supporting the interface will be kept open. Other developers could use part of the system for their own needs. The map service could be used to display the automated fire parameters on your own map. The simulation API could be used directly without an interface so that you could process the result with your own code. The geoprocessing API could be used to extract the data required for fire growth modeling without using PSAS directly. And access to the code that we have can be granted on GitLab, which is a public website. It needed only a free account. The code can be copied and modified to fit your own needs. and Firehawk will be ultimately deployed on a cloud server, either AWS or Azure. So current status and next steps. Uh, in terms of programming aspects, most of the backend is done, and development on the front end is still ongoing, like Alex mentioned in the video. All inputs are stored in Firehawk and formatted to each simulation. So let's say, for example, the 25-kilometer radius extractions. Firehawk communicates to PSAS and sends inputs and simulation parameters and retrieves outputs. We have some validation of outputs that's ongoing. We This may inform also how we will preset fire spread parameters and threshold for simulation. For example, will it stop overnight? Um, and determine the threshold values for weather parameters and FWI indices. We want to release an info report on Firehawk, hopefully during 2022, mainly about the functionality and the usage of the tool. And it should be deployed on a cloud server by the end of this fiscal year. And hopefully the proof of concept will be ready for operational testing during next fire season. We're quite happy. We learned recently that we are going to receive some new funding to move forward from this proof of concept and closer to the vision that we have for this too. So DRDC is sort of renewing our funding for that for 2 more years. So Firehawk Phase 2 will unfold over 2022 to 2024. The objectives is similar, so it's to improve the delivery of fire intelligence at national scale through the development of Firehawk as a specially based next generation fire intelligence system. This will be supported by four main let's say sub-objectives. So enhance implementation of Firehawk at national scale through improved model input. So improve fire weather, fuel layer, ignition points, and parameters and values at risk layers. We want to implement the novel residential structure vulnerability models as a module to predict potential damages to infrastructure. So this comes from some work that we did with Ahmad Abu Alez, who's now a professor at ETS in Montreal. What we did with Ahmad is to develop empirical response functions based on data from the literature that came from real fire events in California and Australia. So we developed two models, two functions, one for direct exposure pixel or buildings, so buildings within the intermix, so where vegetation intermingles with buildings, and we developed one for indirect exposure, what we call pixel, but pixel refers to the raster we're using for the modeling, but rather to indirect exposure buildings or community. So at the interface of, so where the vegetation, the wildland vegetation meets a community or a municipality. So the underlying idea behind these functions are that the closer you are to a fire and the more intense is a fire, the more chances you have of losing your building. And the inverse is to be expected. So the farther and the weaker is the fire, the less chance of losing your building or higher chances of survival. So the model for a direct exposure is loss rate in percentage as a function of fire intensity. So, and the second is a normalized loss rate as a function of a distance from fire edge. So if we take a very basic example, so let's say that the fire reaching your community reaches it at 7,000 kilowatts or so, your expected loss rate if you're close to the fire, so let's say within 100 meter, is 100%. But then if you're building is at about, I don't know, let's say 250-meter distance from the forest, then you apply the 20%, the 0.2 factor here to the 100%. So this means that your loss rate is expected to be about 20% if your house, for example, is situated at about 250 meter. So these functions are we hope to be able to embed them in a framework within Firehawk where we will have the hazard model, so fire growth modeling, coupled with inventory data. So layer on residential structure, for example. And this put together gives us the exposure model to which we apply the impact model, so our loss function that I just described, to output an impact simulation. So we expect that to look like this example right here, where we have two scenarios. One where the ignition is at the southwest of a community here that is pixelized, or to the southeast here as an example. And so we'll have map of the fire growth with the expected loss rate within the community, with impact indicators such as number of exposed structures, number of lost structure, average exposure loss rate, and average community loss rate. And you see it for those two scenarios. I think it was, if I remember correctly, same weather, same everything, really, same community, just different location and thus different fuels led to really different outcomes. To follow the different sub-objective that will support phase 2, we have the improved development of machine learning algorithms to streamline the torchlight fire mapping process and development of a framework to integrate torchlight as inputs as ignition to fire growth modeling. So yeah, I guess you recognize Josh here. So Josh Johnston will join us in phase 2, and we could add other models such, let's say, air tanker effectiveness that we've been working with Ontario. So just to give you a wider idea of what Firehawk is and what it could be, this is like just a diagram that I put up to put things together here. So we have the legend here just showing that in blue we have inputs to Firehawk, in orange we have the models, and in green we have the outputs. And you'll see the dotted box, the white dotted box are for phase 2, and the gray dotted box are example of future implementation that could happen. So these are things that I mentioned already. So inputs to fire growth modeling using PSAS, and to Firehawk we have fuels, topography, weather forecasts, ignition points and perimeters, values and assets that are currently very partial. This outputs fire perimeter that are forecasted and distance to infrastructures. In the future, we could add historical weather just to simulate some fire using historical weather situations. We would like to add more values and assets at national scale. We will hopefully be able to implement torchlight data as inputs. We want to add the residential structure impact model that I just described. So this will mean inventory of residential structure. For now, we're using Microsoft building footprint, but we know there are some lots of buildings that are missing on that layer, especially in remote areas. So this will output residential building percent loss that is also specialized. We could implement air tanker effectiveness model to have an idea of air tanker effectiveness that can be specialized around fire perimeters. I'm actually working with Ontario and Quebec at developing a ground crew productivity model. So once that is done in a few years from now, this could also be implemented in Firehawk. and that would output a ground resource needs model that could be specialized according to productivity. We could be thinking also about wildfire sat data that could be used, let's say, for ignition point inputs, or even some of the wildfire sat tier 3 products that could be shown into Firehawk. And there could be many other things in there. So I'd like, before ending this presentation, I want to thank Franco. I seen him today, so I guess he's on the call, and Brett for helping out with PSAS and giving a huge help to Alexandre, our main developer here on the image here, and also to Software for sharing some data and ideas to make this happen. So thank you.
Thanks, John. That was really great. I think that is it sounds like a really interesting tool that takes a lot of pieces that already exist or are currently being developed and puts them into one place that makes it much more usable for agencies. And I'm assuming agencies would agree. With that, I'll open the floor to questions. I guess if folks want to just raise their hand, I'll try and keep track of folks as they do so, or if folks want to type questions into the chat for John, please go right ahead. John, I was curious if with Torchlight, will that be just used for ignitions, or will the Torchlight fire perimeters be used to augment the fire growth perimeters? Like I wasn't sure how the two were intended to work together in the second phase.
Yeah, these are things that need to be discussed still. I'm not too familiar with the Torchlight product, so this will be on mainly Josh's and Alan's end. But we have been told that we are good for funding, but the charter needs to be written down and agreed upon. So there's many finicky things that needs to be determined in terms of objectives. But the main idea is to use a Torchlight data as inputs to fire growth. But then let's say we have more trust in the Torchlight parameter than the agency or another parameter. We could use this one as a start to the simulation.
Cool, thanks. Maria's answered here that the presentation will be shared on the CIFFC website at some point. Mike Flanagan's asking, are you using ensembles for your weather input? And if yes, how do you present the ensembles?
No, I'm not, Mike. We're actually just using the basic, well, not the basic, but the RDPS model that is available directly on CIFFC's website. So it's, if I'm not mistaken, it's through a WMS or something similar that we were grabbing the forecast from. Yeah, so that's mainly it. So it's very deterministic approach, a single run for each fire for now.
Great, thanks. Cordy, I see you've got your hand up. Would you like to ask a question?
Yeah, can you hear me?
Yeah.
Yep.
Yeah, that was really a great presentation, Jonathan. Thanks very much. I'm really pleased to see how Prometheus and now PSAS has really grown. And the equivalent kind of an application somewhat in the States is the WFDS, the WFDS. And before users can use WFDS, they need to take a course. So I'm wondering, you know, you're going to have your technical report completed, but is the project team looking at you know, other training elements, and in particular a course that you need to be trained or certified in using Firehawk? Thanks again. It was a good presentation.
Thanks, Cordy. No, this is not something that came to as an idea from our side yet. Yeah, for now, like I mentioned earlier in the presentation, it's really aimed at fire agencies, and we hope to give let's say, secured access to this tool to agencies. So maybe one approach could be to ensure that agencies give access to the staff that they think have the sufficient knowledge or background to understand what's going on or what is shown from the tool. But we are mainly concentrated on developing that rather than building teaching material for this.
Thanks, John. Hopefully that answered your question, Cordy. Let's see. Danny in the chat is asking, don't some agencies already have a similar tool, such as preparedness tool that SAFU recently developed and aware in Alberta? So are you aware, I guess, are you aware of other similar tools, and how would this be different?
I'm not aware of any tool that implements fire growth at this level, especially not automated. I know Ontario is working on some stuff through Jordan's work a few years back, but it's different. And we haven't talked deeply in details with respect to the differences really between those tools, but ours uses hourly weather, and if I'm not mistaken, Jordan's or Ontario's tools back then was using mainly daily weather forecasts, was looking further in the future, whereas we're more interested near future time, so today and maybe tomorrow.
Great, thanks, John. Looks like Olivier had a question.
Yeah, salut Jonathan.
Salut.
So this it's both a comment and a question. First of all, great presentation. That's not my comment. My comment is the following, further to Mike's question earlier with the ensemble models. I'm not sure that for day one or even day two that there's a whole lot to gain by using ensembles, although it would generate a little bit of a probabilistic forecast, which it might be interesting to look into that. But I'm not sure that it would be that much of a gain. But the question I have is still related to the weather models, and I'm not sure that we talked about this in the past, Jonathan, but you're using the 10 kilometers deterministic model, and as you know, there is the 2.5 high-res deterministic model, which covers all of Canada. And I don't know if when you mentioned about improved weather models in the next phase, I don't know if that's something you have in mind, but I think there might be a gain there in looking for the use of the high res in terms of better estimating, for instance, the wind field in complex terrain, and the other weather parameters as well. I realize it may be a technological challenge maybe to go with that model, and it's also not available as early in the day as the regional. But is that something you've thought of or that you're going to investigate for the future?
Well, we don't have a specific path for the future for now. Like we know there could be better approach, such as you describe, and obviously you're a very good source of information for us. But I don't like the main idea for now was to get this system rolling as a proof of concept. So it meant grabbing weather somewhere and formatting it to what PSAS needs. So then if we follow another path using more higher resolution weather, I don't think it's much of an issue if it can improve things. So yeah, avenues are open on that aspect, but in terms of improving forecasts, Alex also detected some issues with ECCC's website stability, which could be a problem as well. So this is another thing in terms of exploring whether it's service stability and improved resolution, I guess.
Okay, thanks.
I just wanted to follow up in the chat here. Oh, I lost Dave Schroeder just commented, in case anybody doesn't have access to the chat, that the Aware does not have this functionality, but may be a source of input data to Firehawk down the road. So that adds to that question that Danny had posed. Ashlyn is asking, will the developments be open source? And great presentation.
Yep, it is open source, like I mentioned on the, I think it was on the developer philosophy slide that I had. It's Alex, the main developer, who put that up. So yeah, the philosophy is having something open. So if you have more precise question on that aspect, we could chat on the side and bring Alex to the conversation.
Great, thanks, John. So Jen is asking, I may have missed this, but how are you communicating the uncertainty in your prediction inputs and therefore outputs, especially the uncertainty of 100-meter fuel type for representing actual fuel structure in fire behavior predictions? And are there validation results?
There's nothing on that aspect that is being worked on for now. So yeah, I may not have mentioned that, and this is something that I should probably add to the presentation, is that we're not hoping this tool to be used on an incident level, but rather at a, let's say, regional center level. So it's to take greater order of magnitude decision with regards to a situation or multiple situations. And we would expect agencies to make more, let's say, profound analysis of specific fires of interest. And in terms of, what I say? Well, so we would have those, let's say, automated runs, but also those supervised runs where people will be able to modify inputs or simulation parameters to give them more idea of, let's say, variability that can occur, but what fuels are going to be fixed for now. And if I, Micheline, I saw a question from, I think it's Dave Schroeder, about fuels and ignition position. This is something that we thought of. We haven't implemented that, but most likely we will look at fuels around the ignition point to take a decision on where to, on what fuel to assign to where. So let's say the ignition falls in the water, but then the closest fuel or the most represented fuel around or near that water or near that point is, let's say, C2. So we will assign C2 to the pixel under the ignition point, for example. So this is an idea that we thought of.
Thanks, John. Darcy's asking, will there be a cost for use of Firehawk?
No costs.
That was a simple answer. It's
Yeah.
good. Okay, and we've got from Dan Levine, what are some of the data challenges that you're having or anticipate as you try to gather the necessary information from different agencies across the country to feed into Firehawk? Also apologize for missing part of the presentation. Have you tested model outputs against actual fire impacts seen on the ground? So that's similar to the validation question I guess Jen had.
Oh yeah, well, this, I guess that part of Dan's question is more towards the actual outputs on buildings, for example. So that aspect of the model, like I said, we developed these functions based on data that was published in the literature from fires in California and Australia. But currently we have Ahmad, who's working with ETS, so I call the Technologie Supérieure in Montreal, and they're receiving some GNC funding from CFS to look at Canadian incident and try to improve the loss functions that we have. So this is not really validation, but at least it should be improved model, more adapted to Canadian situation. So for now, we don't have a validation, really. The other part of the question is, what was it? Sorry, what are some of the data challenges? Yeah, data challenges is that there's no national fuels for values at risk layers. So yeah, so this is obviously a huge challenge. And we're not the only one facing that. I had a conversation, I think it was on Monday or last week, anyways, with folks from Geological Survey of Canada, and they were concerned about that also because they're developing newer model for earthquakes, and they don't have national layers of infrastructure. It's very crude. So yeah, this is a challenge. We don't really know yet how we're going to face that. Probably working with agencies directly is the, let's say, easiest way, but it's time consuming also to arrange database together and stuff. So yeah, it's a problem.
Thanks. So Cindy is asking, are the outputs available via WMS, WFS, or other?
Yeah, I'm not very good at all those data formats, but from what Alex told me, it's that the outputs are going to be available for agencies to show in their own GIS system. So you could have access to, let's say, fire parameters outputs and show them in your system, because yeah, I know this could be useful for agencies.
I'm glad you knew what those stood for because I didn't. Good. Scott Murphy's asking, what's the threshold for proving proof of concept? When will you have seen enough to know it's something worth pursuing, and when do you anticipate circling back to, oh, somebody else is typing and I just lost it. Circling back to the agencies before moving forward. So basically, yeah, when you know where you're ready to move forward.
Well, the first thing you guys have to know is that it's currently on Alex's computer, so we have to deploy it on a server, and once that is done, we'll see how stable the system is, and hopefully Subfer is going to be able to use that this summer operationally to see how it responds. And we've had discussion also with Franco from Northwest Territory, and he told us that it might be quite easy for him to grant us access to their fire database to implement the system. So we might actually have also Northwest Territory trying that this summer if we're quick enough to get all things set up. So this is the first thing, and then you well, most of you are familiar with how fire growth works, but it's Prometheus really. So like, how confident are you in using Prometheus? You should have pretty much the same confidence in using our system, but then it's a matter of what fire weather data we input. Most of the time, I guess you use your agency data adjusted with your weather forecasters, and fuels. You can adjust fuels. You can adjust other parameters. We're going to grant access to some of the parameters, but not all, because then what's the point in building this system? You might as well just use Prometheus directly. So the idea here is to gain time, try to reduce the pressure on resource, and give you a pretty good general idea of your regional or provincial situation.
Thanks. I just wanted to check, Cordy, do you have your hand up again, or is it still from your original question?
Oh, sorry, no other questions. I'll probably follow up with an email to Jonathan on some other items. Yeah, that's fine. Sorry.
Thanks, Cordy. No worries. Just wanted to make sure I wasn't missing anybody with their hand up. Okay, so we have another question from Denise or Dennis. Great app and presentation, Jonathan, especially relevant after the last fire season. Two questions. First one, will there be an interface or output that will let the user see the weather variables that are brought into the app?
Yeah, there will be. It's not build up, but we expect to render available to user everything that was used as inputs to the different simulations. So this include weather.
And the second question, I can appreciate how difficult setting some of the default spread limitation assumptions could be. Are you thinking these will vary spatially or be the same for the whole country?
Yeah, we expect those to be varying spatially. and even potentially to different weather situation during a year. So yeah, we don't have a good idea. I guess it will be by working with folks, or because these are sort of quickly adjustable by the programmer. So if let's say we have a situation like last summer and we see that the threshold should be modified for Western Ontario, then we contact Alex. We ask him to just rearrange those, and this is as simple as that.
I think Dave Schroeder had his hand up. Dave.
Hi, Jonathan. I appreciate your long-term vision slide there with lots of opportunities to improve this. And I was just wondering if you could comment on how you see the CFF DRS, the version 2 that we're all excited about, and people will want to do work with fuel inputs. So imagine you've thought about this, and it's probably part of your long-term picture as well. So yeah, if you have any comments on that, otherwise.
Yeah, well, I obviously this came to my mind because I'm involved in that as well. But the thing is that we are not developing PSAS here or Prometheus. We're starting with this tool, and we're building, let's say, around, or rather using the capacity of this tool to produce other things or other results. So implementing next gen CFF DRS into that will need a new software or new Prometheus that implements the next gen system to allow us to implement that in Firehawk afterwards. It may be us that does that. I'm not foreseeing that really, but yeah, this would be my my more simple answer to that.
That's good. Thanks.
So we've got 4 minutes left and 2 more questions. Oh, no, 3 minutes, 2 more questions. So from Steve Taylor, in some cases, there will be much higher resolution fuels, DM, weather forecasts at the provincial scales, as well as fire reports coming in real time. So it's nice to have more tools. Oh, and it just moved again on me. Could it be deployed? Could Firehawk be deployed in agencies' own fire management systems?
I guess so. This will have to be asked to Alex. Sadly, I should have invited him, but yeah, I think so, because yeah, this would need to be discussed, I guess. But like for, let's say, for the programmer to add different layers to the system, it's quite easy. So let's say we add increased resolution fuels or DEM, it's not a problem, but the simulation may take longer to run, obviously. But then to include like other weather sources, this might be a bit more complicated because it would need more more editing or formatting.
I was wondering that as well. That's good, John. Jacqueline is asking, how long does it take for the model to run? She might have missed that.
Yeah, it takes about, well, on the simulation that we did, it takes about 25 to 30 seconds to run from scratch, really, because you just click, it makes an ignition points, and then grab all the input data and runs it to PSAS, outputs it, and show it on the map in, let's say, 30 seconds.
Cool. Lakmal is asking, great presentation and very inspiring proof of concept when it comes to automation of fire growth. Being the first automated solution of its kind, there are a lot of challenges to overcome and lots to refine. There's lots of interest from this group based on the questions. How will CFS continue to work with the fire community to refine Firehawk? Do agencies have to adopt Firehawk and test to provide input? Will there be an opportunity for everyone to unpack and learn from the Quebec experience?
Well, I guess this is still all open. So this is pretty much a first wide outreach to the wildfire community. I've had discussion with SUBFIR, Northwest Territories, Ontario, I'll be presenting pretty much the same presentation in about a week or so. So sorry for CFS's folks. But yeah, I guess it's through those conversation. You can reach me through email. It's easy, but yeah, it's all open for now.
The last question was, or can Firehawk be set up for everyone, all CIFFC members using Modus, VIIRS, fire detection inputs?
Well, it actually, we already have access to everything that's within the CWFIS. So we have the hotspots detection. We have access to that. We could start simulation from those. So it's not a problem for now. It's just like, because these are not confirmed fire as those from the agencies are. So we'll see if we want to start simulation on every hotspots that is detected or not. So we'll have to determine that. Any other problem also with CWFIS data is that it doesn't come in a timely manner, really. So fires are long known by agency most of the time before they show up on CWFIS. So it might not be as pertinent to start simulation from those.
Thanks, John. So we're on the hour. So Franco is just commenting on what that you did a really great job, and I second that. So he's also saying our teams need to converge once again, as you're working on similar tasks. So great work. So thanks a lot, John. Appreciate all the questions you answered, and hopefully you got a bit of feedback that you were looking for. And I think, yeah, as you mentioned, probably folks can contact you with additional feedback as they have it.
Yeah.
Great. So yeah, so folks, next conversation is on February 23rd. So we have Natasha Caverly, Joe Gildchrist, and Amy Cardinal Christensen talking about giving voice to cultural safety of Indigenous wildland firefighters in Canada. So that'll be on the 23rd of February. And thanks everyone for attending, and have a great rest of the afternoon.
Thanks.
Take care, everybody. Bye.